Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I like to start every class with a quote, so if you'll forgive me for quoting myself, the following is from Would Your Boomerang Return? In the real estate industry, there's an adage that all liens are encumbrances, but not all encumbrances are liens. While in finance, every whack is a hurdle rate, but not every hurdle rate is a whack. Real estate was my life for 22 years to the day before I accepted a faculty position. So it seemed fitting, with this being the 22nd lesson in this unit, that we put a real estate swing on this topic. The focus of this lesson is on the real estate of the timeline. We discuss how you might want to keep some space on the leftmost and rightmost sides of the timeline, since you might need to add a period marker for -1 or one or more periods to the rightmost side of the timeline. And we'll see this with the real world example. So here's the real world situation that we'll be analyzing. We've been working with this storyline for the most part for the past couple lessons, and let's dig into this. So lucky you. You expect that you're going to receive the first of 6 $5,000 annual deposits starting today. And you're trying to value this annuity. Remember, an annuity has even or level payments, so frequent payments that are even or level in terms of amount and timing. And we use the acronym FAT. I know that's not PC, but who doesn't want a FAT payment? I know I want one. And so let's work to value this annuity stream. So the first thing that we're going to do is draw the TVM wallet, because that's what we do. This is our solution to analysis paralysis. It gives us the 3 simple steps that we need to work through to analyze and evaluate a real-world time value of money situation. And this is the normal size of a TVM wallet, but I'm going to make 2 of them today because we need 2 steps to solve for this real-world situation. So let's work with the top TVM wallet. I'm going to write in the 5 primary time value of money variables, the inputs, the keys on your financial calculator that you'll be using more often than not. And in the first window of the TVM wallet, let's visualize what we've got going on here. So this is today. It doesn't need to be today. Remember, there's nothing in the time value of money that says that time period 0 is now or today. And obviously, we're making the 0 an O there. But we're at time marker 0, and that is today based on this example. And the first of these $5,000 payments is going to be made today. And here's the abridged symbol, so that $5,000 annual payment will continue through that period of time. And there are 6 payments, and that is a 5. Because remember, the first payment is happening today. So the payment a year from now is the second payment in this series. And we want to come up with the future value. What is the amount for which you would be indifferent at the end of the 6-year investment horizon, or the 6-year investment period? Well, there are 5 years or 5 annual time spans on this timeline. Remember, we like to fill in the blank. So how are we telling time in between period markers? We'll put an A there because that's an annual time span. So we know that only a true annual investment yield is going to work. We need to match how we're telling time in between the period markers and the time span of the true investment yield. So only a true annual investment yield will work for this question. But we need to add some real estate to the rightmost side of the timeline. And I'm going to do that here with a dashed line. This is our real estate that we're adding. So the first thing that we want to do is calculate the future value of an ordinary annuity. We're going to put a rectangle around that. And then over here, we're going to calculate the future value of an annuity due, because that's the building block time value of money equation that we use to support the math. And we're going to circle that. That's what the second TVM wallet is for. We were provided with the true annual investment yield of 2.25%. 0 for PV because there's no lump sum payment here. There is a $5,000 annuity. And first we're going to solve for the future value of an ordinary annuity. Remember, it's ordinary for that value to be as of the timing of the last payment. And so there are 6 payments. If you've watched any of my other lessons, I've talked before multiple times about the relationship between PMT payment and uppercase N when you're working with an annuity. And so we have that here. And the first thing we do is we solve for the future value of an ordinary annuity. And when we solve for that, we get 31,700. Again, you may recognize this number from a prior lesson, but we've changed the storyline a little bit. $31,738.99. So that's the future value of an ordinary annuity. That's the amount that we were looking for in the rectangle. So now let's move on to the next TVM wallet. And we want to take this from the 5th period. Obviously, this is not drawn to scale, but I have a little more room, so I'm going to play with it here. And we want to take this value, $31,738.99, and we want to calculate future value. And that's really the future value of an annuity due. So we're going to circle that. So again, I'm going to write in these inputs, the keys on your financial calculator, the variables in the building block time value of money equations. We've got our true annual investment yield of 2.25%. We have 0 for a PMT payment here. Why? Because we've calculated the future value of the ordinary annuity, so it's become a kind of hypothetical lump sum payment. And we need to do what I call the switcheroo. Notice we changed the sign here. It had been a positive no sign value before. So now we're going to change the sign. We're going to switch the sign. That's a better way to say it. That's why I call it the switcheroo. We're going to switch the sign, and we're going to also switch what key we use. Because before, that value was in the FV key. Now we're going to put it in the present value key. So negative $31,738.99 to solve for the future value of an annuity due. There's one period, one compounding period, because if I wanted to draw this like the snowball illustration that I've shown you before, future value of annuity due, it's like our snowball. And I think the action happens below the timeline in the elbow of what I call the indifferent lines. And so we're simply multiplying by 1 plus I raised to the power of uppercase N. And so what does that look like here? 1.0225 raised to the power of 1, because there's one compounding period. And so that's how we get this quote-unquote snowball to grow or to compound. And when we solve for the future value of what is an annuity due, we get $32,453.11. So there's our answer. So we added real estate to the rightmost side of the timeline. Yes, you can do that. And remember that this question contemplates, or this real world situation contemplates, a 6-year investment horizon. And if we look at this timeline, we've got a 6-year investment horizon. We also have 6 $5,000 payments, the first starting today and the last being received 5 years from today. So now let's move on to the next question. And well, let's first double check because that's what we do. And we double check here with the future value of an annuity due, the building block future value of an annuity due equation. And here's what that equation looks like. 1 plus I raised to the power of uppercase N minus 1 over the true investment yield. And here's the add-on expression, get ready, times 1 plus I. Now, in parentheses, I'm not going to go back to the last slide, but do you recognize this right here from the elbow of the indifferent line? That's what moved the future value of an ordinary annuity from the end of the 5th period, the beginning of the 6th period, to the end of the 6th period, the beginning of the 7th period, because remember the beginning is the end. That's the add-on expression. That's what compounds the value one additional period. And that's the only difference between the building block future value of an ordinary annuity equation which is that, and the building block future value of an annuity due equation, which is written like this. So let's get about solving this. Future value of an annuity due equals, we have a $5,000 payment, and let's put this information in square brackets, 1 plus 0.225, because we have a true annual investment yield. We're telling time with an annual time span in between period markers. How many $5,000 payments are there? There are 6. That's what I'm talking about when I talk about the relationship between uppercase N and PMT payment when we're dealing with an annuity. Minus 1. In the denominator, we have the true investment yield, which in this case is a true annual investment yield. And then we work with the add-on expression. And when we solve for the future value of an annuity due, we get $32,453.11. I'm going to circle that because that is the correct answer. Okay, now let's analyze the present value of an ordinary annuity and the present value of an annuity due, because again, we need to draw 2 TVM wallets. So we're going to stack them. And I think we had enough room last time, so we should have enough room this time as well. And let's start with the first TVM wallet. I'm going to write in the 5 primary time value of money variables. That's PMT, the PMT payment. And again, we were provided with a true annual investment yield of 2.25%. There, let's visualize in the first window of the TVM wallet because it helps to visualize. Again, here's the abridged symbol. And again, we're told that this is a 6-year investment period, but we want to add real estate to the leftmost side of the timeline this time. And yes, you can have a -1 period marker. So $5,000, the first payment happens today, and the last payment is expected to be received, that's a better way to say it, 5 years from today, or 5 years from now. So we'll clean this up because again, period marker 0 does not need to be now or today, but for this question, it is. That's the assumption. So we want to first determine the present value of an ordinary annuity. So I'm going to put a rectangle around that. And then the present value of the annuity due. So I'm going to circle that. Remember, for present value, it's ordinary for the value to be 1 period before the first payment in the series when you're dealing with an annuity. So let's write in the values. We have 6 $5,000 payments. Future value is 0. And let's write OA in parentheses here to remind us what value we're solving for. So we're solving for the present value of an ordinary annuity. And when we do that, we get negative $27,772.38. So that's the first step. Let's go down to the second TVM wallet. This time we want to move from -1 to 0. Now, if you haven't watched the I think it was the 21st video or lesson, you might be saying, well, couldn't this guy just use begin mode on his financial calculator? And the answer is no, because I don't advocate begin mode for all the reasons that I described in the last lesson. So let's write in the values. Again, we have an annual time span in between period markers, so only a true annual investment yield is going to work. Same thing here. We still have an annual time span in between period markers, so only a true annual investment yield is going to work, and that's great because that's the yield that was provided, a true annual investment yield of 2.25%. 0 for the PMT payment because now we have a hypothetical lump sum, and that hypothetical lump sum is this amount that we just calculated. $27,772.38. So we ultimately want to solve for future value here. So these are the indifferent lines that I was talking about. And in the elbow below the timeline where the action happens, we have times 1 plus I raised to the power of uppercase N. So there's one period. And while we're solving for future value, what this value really is the present value of an annuity due. So if we wanted to, we could put AD here and round out the F and make it a P. Now it's still the future value key, so we'll leave it that way. But just for illustration purposes, that's really what we're doing. That's really what we're calculating. And we get $28,397.26. So let's double check our work. And this time we're going to use the building block present value of an annuity due equation. So the timing of this value is as of the first payment in the series. 1 plus I, that's the true investment yield, minus 1. Got the same thing down here below, and then times I. And then our add-on expression. Remember, that's what was in the elbow below the timeline. That's what compounds that amount, moves it to the right one period. But it happens below the timeline because, remember, we can't add or subtract or compare monies in different points in time. And that's why, in my mind's eye, I don't see money moving along the timeline. I see it, the action happening below the timeline. So the present value of an annuity due equals $5,000. That's our payment. 1.0225, that's our 1 plus the true investment yield. Here, the true annual investment yield. How many of those $5,000 payments do we have? 6. See what I mean by consistency? I've talked about this before. I like being able to tell you that uppercase N, there'll be that relationship between the number of payments and the number of PMT payments, I should say, when dealing with an annuity. 1 plus the true investment yield. So that's 1.0225. So that's 1 plus the decimal format of the true investment yield, 0.0225. And here we go with the add-on expression, 1.0225. And when we solve for the present value of the annuity due, we get $28,397.26. And that's the correct answer. That's a good thing. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. Since my area of expertise is in real estate, that's how I tend to see the world. Between the time I typed the first words and the end in the manuscript that would later become Would Your Boomerang Return, I embarked on what people in the real estate industry like to refer to as a tear down and rebuild project. Simply put, I put myself in the shoes of someone who had never before been introduced to the time value of money and asked myself the question, how would I like to have learned about the mathematics of finance? This question served as the North Star for this project that had me wearing a student's shoes and an architect's hat. Finance professionals who can't measure twice or double check their work might get cut once others are onto them. If you haven't purchased your copy yet, all the important information on this all-important topic is gift wrapped within the cover of Would Your Boomerang Return. Until next time, enjoy the gift that is the present.